Hey guys, welcome back to another episode of Simuleo. So today we're going to continue working on Huffman Encoding, kind of like what we were doing yesterday. There's a lot of stuff to be done here. I realize that we may not finish the canonical Huffman Encoding today. In fact, I'm like 90% sure we won't, because I haven't quite gone through figuring out what exactly the canonical Huffman Encoding does differently than standard Huffman Encoding. So there's a lot of stuff to do here. And I guess before getting started, we'll just, hang out, talk a little bit, wait for people to come in. I'm not really sure how today's going to go. I think we'll see how it goes. Hey JSPP, thanks for coming in. Truth be told, last night I spent a little bit too much time working on work stuff, just reading some papers and trying to get some stuff done. My code for work is just for some reason randomly giving me weird errors and I can't figure out what the deal is. It's just, one of those things. I guess I'm fortunate enough to work in a working environment that allows me to work at my own pace. On the other hand, it's just slower than I want it to be, So I spent a lot of time last night working on that instead of looking up the canonical Huffman stuff. So yeah, it happens. Unfortunately, I did not get as far as I wanted to there. Fortunately though, we did kind of write down the outline of everything we needed to get done yesterday. I think we worked out all the technical kinks if I remember correctly, so we should just be able to go through today and just write all of the auxiliary functions and have some sort of basic Huffman encoder working. Decoding will be a little bit more difficult, but it should be just about the same. And then we can take a look at the canonical Huffman stuff together and go from there. Before continuing, I wanted to point out just some brief housekeeping stuff that I said a few days ago. So last Friday, I made a note here on this channel, but I don't think I said it appropriately. So I basically said I'm not focusing on YouTube anymore here on this channel, and it's something that I think kind of made some people a little bit worried about the future of this channel and the direction it's going, because up till now, I've basically been focusing on YouTube, I made a YouTube video. My Twitch stream was basically working on animations for said YouTube video. The algorithm archive didn't really make sense without the YouTube video. And this is something I kind of wanted to avoid. And that was what I was trying to say the other day on Friday. It's not that I don't like YouTube, although as I mentioned before, it is very, very stressful for me to make videos. It's that YouTube itself is not the platform that I want to build a community on. And the reason is quite simple. YouTube's algorithm does not naturally favor people whose content has them leave YouTube. And that's the exact type of content that I have. It's a video where people will watch it and then they leave to work on the algorithm archive or to work on their own thing that they came to watch the video for. The point of the video isn't to keep people on YouTube, keep people watching more content, to get them engaged in that area of this community. It's to get them engaged in writing the algorithm archive. It's to get them engaged in just hobby coding. It's to get them to join the community and kind of enjoy the other aspects of the community, not necessarily watching YouTube videos. And that was the thing. YouTube leads to more YouTube, and that's not what I want. Twitch, however, and this is something I do like about Twitch, leads to more community engagement overall from the people who find the Twitch channel. And so that was something that I've realized recently, and it was one of the reasons why I made the decision to kind of see this project as one cohesive I guess you could say goal, so Twitch is where we live stream, we learn things together. YouTube is where we kind of concatenate everything into one cohesive single short video where we give everyone what we've learned, and then the algorithm archive is where people go for more information and to get a really in-depth understanding of what we're covering. And so that's what I realized. The algorithm archive isn't in-depth enough, Twitch isn't twitchy enough, and that's kind of how it was. So that was what I meant to say last Friday. I just didn't know how to put it cohesively together. Hey Gustorn, thanks for coming in. Okay, so that was about it. I don't know how many people will pop in today, but we'll see how it goes. So I'm going to CD into projects Huffman. And for the new people, 1 second, that's not right, Simuleos Huffman. And CD projects, Simuleos and Huffman. Oh, I left off at a bit of a cliffhanger yesterday. I just remembered. Yeah, we're going to run into weird technical difficulties in just a second. But let me go ahead and open up Zernal. And go ahead and describe what exactly we're going to try to get done today. And then we'll move on to the next bit. As always, there's a bit of a bug here. Whereas if I try to write, it's not going to write. So I'm going to have to close it and open it again. I don't know why this bug happens. No idea. Maybe one day we'll be able to fix it. But for now, It's fine. Just open it, close it again. It's fine. So we're working on basic Huffman encoding. Huffman encoding. I've covered this twice now, so I don't really intend to cover it in so much depth today. If you've missed it for the past few days, go ahead and go to one of the previous channels or one of the previous streams and we can talk about it there. But for here, let's just say that Huffman encoding is a way to create an optimal set of bits that minimizes a particular term, which is basically defined as the length of the number of bits. So basically, if we have a string that we're reading in, let's say the string is hello. With Huffman encoding, this will turn into binary strings of ones and zeros, and Huffman encoding ensures that that binary string of ones and zeros is as small as possible. So we want to minimize, let's see if I can put some eyes on there, the encoded bit string. Bit string. Let's pretend I can actually write correctly, and yeah, that's supposed to be a D. I put one D down, put another one that makes even less sense. Okay, so how does this happen? Well, first of all, we put all the letters down in the order in which they appear. So the most frequent is L, then we have H, E, and O, which are all of equal frequency. Now, the frequency in which they appear will be 0.2, 0.2, 0.2, and 0.4, adding together to 1. If I didn't mess up, my bot should send a message now if he's starting in the stream. Oh, on Discord, I guess. Wait, where does it send the information? Let me see real quick. If it did appear correctly, then let's pop this over to this desktop, move that over there, and now let me see if I can find Discord here. Okay, so basically when I end stream, we'll check it out when I end stream. Okay. So what do we do with this information? Well, the information, what we do with it is we basically add the two lowest values together to create one larger node. So these add together 0.4. Okay. Now we add the two lowest again, which will be this one plus one of these two. So we're going to add this one and this one together to make 0.6, and then we add these guys together again to be 1.0. In fact, maybe I was supposed to add... One second. Maybe I was supposed to add these two together back here. Let me think. I think I can add either of them together. To test, let's see. So there's this parameter called L. L is basically a sum of all the probabilities times the length of that particular code word. So in this case, the code word length looks like the following. So it should be L, H, E, O, and it should be 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. Wow, that was meant to be a table, but I just could not align anything. Let me try this one more time. H, E, O, 0, 0, 0, 1. 1, 0, 1, 1. Where basically we go through the tree like this. So 0, 0, 0, 1. 1, 0, 0, 1, 1. So every time we go up, we take a 0. Every time we go down, we take a 1. Now, what I want to check real quick though, Gustrum, what I want to check real quick is to see if both alphabets give you the same L. Because if they give you the same L, then in principle either one would have done. And that was something I hadn't really considered, I guess, but we'll see. Okay, so if we would have gone the other way, it would have been a different set. So that set of code words would have looked like, 1 second. This here, 0.4, this here to 0.6, this here to 1. And so that set of code words is simply 0. Let's see. Man, I just cannot keep things aligned today. Then we have 1, 0, 1, 1, 0, and 1, 1, 1. Okay, so these are the two sets. So let me see. So the two different L's will be basically 0.2 times 2 times 3 plus 0.4 times 2 for the first one. and it will be 0.2 times, what is it going to be? It's going to be 6, 7, 8. Wow, I'm not writing anything right. So this is going to be 8 plus 0.4. Okay, so the answer here is going to be, what's 2, 3, 6, 6, 12, 12 plus 2. It looks like. Am I incorrect there? 0.2 times 6 is going to give you 1.2, plus 0.4 times 2 is going to give you 0.8, so that's equal to 2. And in this case, we have 0.2 times 8, which is going to be 0.6, so it's also 2. So in this case, yeah, you're totally right. Both trees would have given you the exact same result in terms of the amount of compression for this particular system. Okay, that was a little bit messy. I apologize for that, but we covered it for the past few days, so it should be okay. What else is I going to say here? Okay, so today we had some basic stuff written. Yesterday we kind of put the skeleton of all the stuff that we needed to do for Huffman Encoding down. So today we're basically going to go through and update everything such that the Huffman Encoding scheme that we've written in Julia works. And there's a few things that I think I screwed up on yesterday, and there's a few things that I need to figure out as I go along, just because I've kind of forgotten a lot of Julia syntax, as you guys noticed the other two days. So that's what we'll be working on. And of course, if you guys have any questions, comments, concerns, you guys can think of any way to make the code more efficient, feel free to let me know in the chat. We're doing the right system, don't we? Let me think. Open link. As a note, we will be using priority queues, and again, this was discussed yesterday. Oh, that is a very long bit of code to put into the algorithm archive. Let me think. Sorry for the yawn. Before getting started, I'm going to get a quick sip of water, and then we will go from there. As I mentioned yesterday, and I'll probably mention one more time, I'm kind of keen in the future to try this idea of the software RAID idea that I mentioned yesterday. But I don't really know how to get started there. So the software RAID idea was basically, we talked to some GitHub maintainers, and we asked, hey, what can we do to help? And then we just get a whole bunch of people together at a particular point in time, and we just basically hit every issue at once. And kind of go through it all together, kind of talking together on Discord, having some sort of stream, making kind of this fun event, you know, maybe have some music and stuff in the background, I'm not sure. Just somehow make it so that this is a fun event that we can do together as a community, and can really just like push through an open source project together. And I have this idea, and I kind of want to see it through, you know, I want to try to get it to work. You can decide priority queue or list. Well, JSPP, I'm implementing this with a priority queue, but can't really make it shorter. Yeah, so I don't know. I'm using a priority queue, so that's fine. But we'll see how it goes. Okay, so let's go ahead and go into vi huffman.jl, and here's the thing that I realized I screwed up. Julia, Huffman.jl. First of all, there's probably a whole bunch of syntactical issues because I didn't actually do this yesterday. Yes, look at all these fantastic syntactical issues. That's what I thought. No method matching node. I don't have the ability to naturally create a node, an empty node, basically, in Julia. And that was the thing that I need to be able to do. So I have this written somewhere else. Let me go in there and see what we have. As far as my archive is concerned, the thing is, I know that we had this huge discussion about keeping the code clean and everything, but the thing is, if it's implemented differently in another language, there will probably be some language. In which the priority queue is actually very, very, very difficult to implement. And maybe in that case, if it's not standard, maybe that's okay in that language. You know what I mean? List plus resort is O(n) squared. Binary heap-based priority queue is O(n) log n. Yeah, fine, fair enough. Yeah, that's definitely better. Okay, so let's go ahead and get through and figure out what the problem is here. Again, I actually know what the problem is. I need to find a way to generate a an empty node or something like that. So let me go ahead and do this as I've done it before. Let me just pop this up over here. This is another terminal up over here. Let's put it up over on this one, the secondary terminal over here. Okay, good. So we're going to cd into projects, and actually I put this down for a Julia skill pill, so I think it's going to be skill pill Julia. Yep, ls cd into examples ls real quick. What do we have? Data structures ls real quick. vi binary tree .jl. And I think what I did, yeah, this is what I thought. Okay. So in order to get the binary tree to work in Julia, I had to do some weird things real quick. So let me think. What I did back then is I created an abstract type, which was a binary tree. Okay. And from that abstract binary tree type, I then defined a specific binary tree with a weight, a bit path, a left and right node. And then, let's see, I created a typed empty, which is within the overall binary tree, so that every time I needed to create an empty, I could just basically create the empty node there. And that's what I ended up having to do. Now, if you guys have any better ideas on how to get this done, feel free to let me know, but I think I'm going to have to implement something quite similar here, because this is the only way I can think of to do it at this point in time. Yep, okay. However, this was to get over a compilation issue that we didn't seem to have this time. Let me think, is there a way? Let me mess around with Julia real quick. Just open up a Julia shell over here, and let me see if I can think of something. No, I think it's because we're gonna have to... Okay, let me try some things real quick. We're just going to kind of figure out how Julia works underneath, and then we can go from there. Again, last time I did this, I created an abstract type, went through that way. This time I wanted to try it slightly differently. So here we have the struct, and the problem is inside of the struct, we have the struct itself. So we have struct node, and in here we have, let's say child, just because we don't want to overcomplicate this thing, and it is of type node. And we also have some sort of weight, which is of type float 64. That was a 75, 64. And here. Okay, so now the issue is creating this node. Now, what I could do is I could create some sort of empty node. But the question is, how do I create that? So for example, let's say I want to initialize this node. I could just say n is equal to node. But then I have to initialize this first node here as something. So do we do this? And then we just do some sort of weight 0.1. This is obviously not going to work because node doesn't exist, right? So we don't have any way to construct it that way. We can create a, let me think. We could somehow create an empty node, but then again we have the issue where if we're going to create an empty node, let's try that. If we want to create an empty node, then we still have to initialize the node within as some sort of empty node. So then we have node, you know what I'm saying? And this doesn't work out. Of 0.0, let's say 0.1, something like this. That's obviously not going to work out. So here's what I did last time. Abstract node. And let's see if this still works. Abstract node, abstract type node end. Okay, interesting. I'm going to check something real quick over here. Julia, binary trees, .jl. Warning, abstract BT is deprecated. Abstract type BT end instead. Let's see if that still works. vi binary tree .jl abstract type BT. This is a very weird thing to do, but let's see what happens. Julia binary trees. Okay, well at least the syntax isn't deprecated. We need the empty node because As we're creating the binary tree, let's just go over here. Maybe we can get away without an empty node. But here's the thing. We create a single node here. This node will have a whole bunch of different things. It'll have a left child node, a right child node, and a parent. Okay? Which I'll just draw going straight up. These are all different nodes that it's attached to. It also has a weight and it has a character, but that's fine. The main thing that we're having trouble with is the parent node, the left and right node. So because it's kind of recursive and it naturally has all these different nodes, if it's a leaf node, for example, then these guys, it won't have left or right nodes, right? Like it won't have children nodes. So if it's a leaf node, it's at the end of the binary tree, then these guys should point to nothing, right? Like we shouldn't have anything in these spaces. If it is a, like the root node, which is the very top, then it shouldn't have anything up here. But it should have two children nodes. If it is somewhere, it needs to have, if it's somewhere else in the tree, then it'll have all three. But as we're constructing the nodes, we don't really know which nodes those are to point to what and what. I would just put in the priority queue again and create the next. Repeat until one root node is left. Wait, in the end we need a tree. At least so far as I'm aware, I can't see any way to do this without some sort of tree. Which means that you're totally right, just put it back in the priority queue again and create the next empty node. But that's what I'm saying, we need an empty node. Put it in the priority queue again and create the next empty node. That's exactly what we're doing, and I don't understand how this this solves the issue of having the empty node. The problem I'm having is basically like initialization and stuff with Julia. So let me see if I can figure out what you're saying. So we have some sort of priority queue. Okay, so this priority queue has a list. We never need a parent for that. Maybe you're right. Maybe we don't actually need a parent. Yeah, maybe we could get away without a parent. Maybe we can get away with just having left and right nodes. You're probably right. For some reason, I have a parent down, but yeah, you're right. We don't need a parent. We can get away without a parent. But we still need an empty left and right node for the initialization here. Yeah, so we definitely need that. Okay, as far as I'm aware, so let's say this is our binary tree. Right? These guys still don't have anything down here. Just do tree. Yeah, I agree with what you're saying. We do tree traversal from the root node. We don't need parents. You're right. I kind of overlooked that, but I still don't see these guys down here will still have nodes down here, and those nodes will point to nothing, right? So these should point to empty nodes. Yeah. Only the parent knows the children. Children don't know their parent. Yeah, but I'm still saying I still think we need empty nodes here. And even so, we need empty nodes for the initialization and everything like that. So yeah, okay, I think that's probably about right. Besides, it is possible with Julia syntax. I just have to think about it a little bit more. So let me go back over here. So again, what I've done previously is just create some sort of abstract type for the binary trees, and this seems to work okay. Now the question is, does this work with structs? And that's a good question. Abstract struct, because now my understanding is that they don't like, let's say BT tree, okay? End. Deprecated syntax, abstract type false B tree. Let me try this again. Abstract type BT end, because it works with types. Now I need to figure out what the difference is between types and structs in Julia, because I don't know how to get this to work without types. So, So before I created an abstract type for binary trees, and I had a node within a binary tree and an empty within a binary tree. Yep, that's basically what I had. I just called it type B tree for some reason. I should have just called that node. And then from there, I created some sort of constant empty node. And then every time I initialized nodes, I could just initialize them with empty nodes. And that was relatively straightforward to do. Now, the one thing I didn't like about this was that the empty was actually on the global scope. But that's easy enough to fix. Yeah, that should be easy enough to fix. Okay, so let's go ahead and implement this for now. And again, we might need to modify things later, but for now, this will be the first test, and I'll go back through and see if there's a better way to do this. So using data structures, here's what I'm going to do. We probably use ints instead of doubles for weights. I can go ahead and delete this note because we have already changed that to ints. And as JSPP mentioned, I don't think we need a parent anymore. So let's go ahead and go down here and do abstract type binary tree, which I think I'm just going to keep doing BT and then end. And I'm going to say up here, creating abstract type for binary trees. And I realize this is what it says, but just BT is not quite as clear as I want it to be. Okay, so down here, we're going to say we're going to create a type, which is node, and this is going to be held within the abstract type of binary tree. Right, so now the idea is we have some sort of binary tree, and then down here, these guys aren't going to be nodes, but they're going to be part of the abstract type, which is binary tree. So now, again, we don't know what these guys are, but we know that they're going to be something within binary tree, meaning they could be a node, or they can be the thing I'm going to define next, which is going to be an empty. So we're going to say type empty, which is within binary tree. And there's actually nothing in here, it's just end, right? So now I'm just going to go ahead and do this and put this up here. Okay, so now when we define the node, we can switch between it being an empty and it being of type node. And this allows us to define the left and right nodes as empties as we will. And that should be okay. Okay, so now let me go through and every time we create a node, let me just change that to an empty. We should be okay there. It's probably more efficient to have some sort of empty up top, but for now, let's just go ahead and go through and change these guys. There. And there. And I think I defined nodes again down here. Let's go ahead and do that too. Node here, this needs to be empty. Now let's see, is there any other place that I create nodes? I'm not quite sure at this point. Let me go back over here. Let's quit out of here, close that terminal, and then let me run a quick write, and let's run Julia. And I guess it's going to be Huffman.jl. Okay, priority queue. We still have a whole bunch of errors, but I think they're different errors than before. Can I convert an object of type empty to an object of type binary tree? Okay, I did something wrong. So there's no null or optionals in Julia. As of the last time I looked this up, there wasn't. But again, I need to look this up one more time. So let me write this down in actually my my notebook real quick, so I know to look it up a bit later. Hey, Oski, thanks for coming in. Again, so what Julia has is an extensive type system that allows it to do a whole bunch of different things. But again, it works slightly differently in that respect than a lot of other languages. So let me go ahead and write this down and say, I'm gonna look for a cleaner way implementation of the binary tree. Okay, good. So I'll look up this tonight or something like that. Again, guys, if you have any comments, questions, concerns, anything like that, feel free to let me know and I will totally address it as soon as I see it in chat. Following the discussion from earlier today, I did want to point out that if we end up going slower through this or slower through this than I expected, that's perfectly fine. My whole point in that discussion saying that, you know, Twitch and YouTube and the algorithm archive are all one cohesive unit was saying that if I'm not happy with the quality that we're producing on any of the platforms, we simply delay it until I am happy with the quality. That discussion is basically a quality over quantity argument. I just want to make sure that everything that we're putting out is clean, clear, and useful for everyone so that we don't put any crap in the algorithm archive anymore. I want to make sure that it's good and that it is effective for what it needs to be. Okay, so let's go ahead and go through all these errors. Huffman priority queue. Priority queue here is deprecated. Use priority queue KV instead. Okay, that's fine. We'll go through that in just a second. Let's see, what do we have here? Open link. How does null or nothingness work in Julia? Unlike many languages, for example C, Java, Julia does not have a null value. When a reference, variable, object field, or array element is uninitialized, accessing it will immediately throw an error. This situation can be detected using the isDefine function. Some functions are used only for their side effects, which do not need to return a value. In these cases, the convention is to return the value nothing, which is just a singleton object of type void. This is an ordinary type with no fields. There is nothing special about it except for this convention, and that the REPL does not print anything for it. Some language constructs that would not otherwise have a value also yield nothing. For example, if false end. For situations where a value exists only sometimes, for example, missing statistical data, it's best to use the nullable type T, which allows specifying the type of a missing value. The empty tuple is another form of nothingness. So I guess what we want is nullable. Okay, so what if we do up here, and we change this to nullable node. Oh. In principle, that should be what we had before. And then we should be able to... In principle, that should work. Now, is it better to use the nullable in this case, or to use the empty? Okay, how about this? We'll get something basically working. Okay, using the empty thing that we had before, right? And then we'll take a step back and we'll ask which one is better between the two of them. So we'll show two different implementations and then we'll go from there. So the other thing I want to do is look up nullable of node. Okay, so we'll go back through this in just a second. So that's another thing to bring up. Thanks, JSBB, appreciate that. Okay, so priority queue is deprecated. That's probably fine. We'll just fix that one. So where is this going to be? It's going to be in create tree 32. Here. It says priority queue node int 64. That is... Okay. So then we want priority queue type K type V is deprecated. Use priority queue KV. Nodes equals priority queue. So I guess it's just going to be the following. So that should fix the deprecation warning. And this is error, load error cannot convert an object of type empty to an object of type binary tree. This may have arisen from a call from the constructor binary tree. But after that, the nullable is the language's own thing. It should be better. But the type thing is also the language's own thing. The truth is, the abstract typing might make more sense in Julia. For some reasons I wanted to talk about in just a second. The nullable might not make as much sense. Because again, Julia is kind of sort of saying in that statement there, they're basically saying that Julia doesn't like having these empties, or this kind of nullable object. And it's kind of just in the case that you need it, but it's probably not that you want to use it. And the type structure is kind of something that Julia does often advocate. But then again, in Julia 0.6 or whatever we are now, maybe things have changed. And that's the thing, the Julia environment is kind of rapidly evolving. So I need to kind of look up which one is more, I guess, expected from everyone here. So let me go ahead and go up here and define, like we had before, creating empty node for later. And we're just going to say ET is going to be equal to empty. Here. And let me just pop up over here one more time. Another terminal and see what we have. Okay. So now we're going to cd back into projects, and again the skill field that we were on before. ls there, and let's go into cd examples. cd into data structures, where I had the binary tree. And let's see, we have the binary tree here, constant at empty. Okay, so I guess if I do a quick const. Oh, you know what? Maybe the const was there. We'll see. So now instead of just calling empty here, we put in a specific value that is et, and maybe that'll work. And if it doesn't work, we try something else. Oh, wait a minute. Maybe that was the error. Error load error. Let me go ahead and clear a couple times, and let's try that one more time. Method no matching node empty in64 string. Where are we? We are. Oh, I know the problem. Down here, because we no longer have parents, we don't need that guy. So this should work. No. Can I convert object of type string into an object of type character? Oh, that's fair enough. That's a little bit later. So create tree 46. Cannot convert. Oh, so I guess characters are going to be. Oh. Invalid character literal and expression line 46. Dang it. So that means for the key, let's just. Okay, here's what we're going to do. We're going to change this key to a string. Okay, and then we're going to pop down here. And what I want to do is pop down here and just change this to an empty string for now. And let's go ahead and run Huffman. juliahuffman.jl, error, load error. Good, fantastic. Let's see, what do we have here? Cannot convert object type character and object type string. Okay, so maybe version from call. Is this not the same error we just ran into? Maybe I forgot to write it? Oh, key down here. Key is DQ waits. Okay, where do we have waits? Waits is going to be a priority queue. Waits equals 1, waits of I equals 1. So what I want to do here is make sure this is a priority queue of. I don't need this empty anymore. Waits is equal to a priority queue. Has key waits of I. For I in phrase, so that's naturally a character. You need to donate $1 every time you type make. I actually, a long time ago, back when I just started this like 3 years ago, I wanted to try this series that was called Working Out with Code, and the idea was I would code. And then every time I had a compilation error, I would like add a push-up or add a crunch or add something to this long list of crunches and push-ups and things that I had to do at the end. And then we would like work out for a little bit afterwards. This was a dumb series. It did not work out. But I kind of wish it would have, because that would have been really nice and would have like combined working out and streaming together so that I could go into work directly after streaming instead of having to go to the gym after streaming. Anyway, it was one of those things. Okay, so this is an issue between calling the key a string and calling it a character. And the fact that we don't have like a nullable object. It would be the Hulk by now. I mean, I do work out for an hour every day. It's not like I don't work out. Well, most days. I think, like for example, I miss a day every now and again. But for the most part, I work out for an hour every day. But of course, if I don't, I get like massive back pain. So it's kind of one of those things that I need to do a specific, kind of movement type of thing just to ease my back, because otherwise I run into a whole bunch of issues. Swimming is by far my favorite exercise to do. It really helps you out. So if any of you guys wanted to have a good aerobic exercise to kind of just do, swimming, that's it. That's the aerobic exercise you need. It's really, really useful. In my opinion, of course. We typically do a set of about 5K in 2 hours, something like this, just switching between the different strokes. It's not particularly complicated, relatively straightforward. So if you want, I can give you workout tips. Actually, I really wish I could like stream from the pool, like, you know, or something like that. Like I could like create a video of like my workout routine swimming or something like that. I think that'd be a lot of fun, but I don't think too many people would be into it, especially not because this is a programming channel. Okay, so what do we have here? Constructor falls back. So what we need to do is figure out, is this a character or is this a string? If it is a character, okay. Yeah, I don't know. Okay, so we'll keep it as a string, and what we'll say is for I in phrase, but what we want to do is say for convert I to a string. I think that's correct. I not defined. Dag freaking nabbit. For I in phrase, what we're going to say is temp string string is going to be equal to and then we just go here to temp string and we do weights of temp and weights of temp string. If I can get this right one of these days. And let's go ahead and run juliahuffman.jl. What's the problem here? Convert must be a type. Oh, okay, so this means it needs to be string I. What's the next one? Let's go. Convert type character to an object of... What do you mean you can't convert an object of type character to an object of type string? What? Come on. Come on, that seems like a very typical, you know what I mean? Like, come on. Of all things to convert. Converting. 1 second. Strings. Julia. Why? You can't. Okay, what do we have? How to convert a character to a string? String C. Okay. No, it has no field parent. Create tree. 46. Temp node parent, you are correct. I've deleted the parents. Okay, that one ran. Good job, guys. Now we have to do everything else. Ah, man, this somehow got super complicated. I apologize for that. But that's okay. It always gets complicated, then we make it simpler to begin with, or at the end. We're gonna come back to this abstract type stuff later at the end of the stream. For now, let's go forward and let's go ahead and create the depth for a search function and go from there. The hope is that it doesn't get too much more complicated here. I think this was the most complicated part. And again, we're using a whole bunch of different data structures and stuff to make this clean. And when I write the chapter in the algorithm archive, I'll go ahead and make this clear. I think what's going to happen is we're going to have 2 chapters out, well, 3 chapters out technically for this particular algorithm. We'll have one, the basic chapter on what data compression is and what it attempts to do. Then we'll have another chapter on Huffman encoding, followed by another chapter on canonical Huffman encoding. Now, what I kind of want to do also is write a chapter on Shannon-Fanon encoding. Wait, Shannon-Fano encoding, and also another chapter on Shannon encoding itself, because these are also very, very interesting in their own right. They're kind of historical algorithms, though, and never actually used in practice, because Huffman encoding just kind of beats the snot out of them in terms of implementation and in terms of like the amount of bits compressed at the end. The compression ratio is higher with Huffman encoding than other things. So that's also something to keep in mind. So let's see. The other thing too is I'm trying to find a way to make the algorithm archive a little more graphically appealing. You know what I mean? Because right now it's a textbook, don't get me wrong, textbook's kind of nice. I need some better figures and stuff like that. So I think one thing I'm also going to spend a lot of time this weekend on is trying to find trying to make some really good, clean, crisp figures for this chapter, you know? I'll probably be doing this with Cairo, and I may or may not do it on stream, but these will just be still images. They're not going to be anything particularly complicated. So it's not going to be like animations or anything like that, so it shouldn't take too long. I think I'll still do the visualization here on stream, but it's going to be much more straightforward than what we were doing before. So it shouldn't be too incredibly complicated. I'm just trying to find a good way to generate these, like the trees and all this kind of stuff. I also need a good way to generate, like, you know, a flow diagram to say, hey, here's the first step in the algorithm, here's the second step, here's the third one. Yeah, you're right, the images in tree traversal are too big. The issue is that they scale depending on your screen size. So that's something else. So all the images are too big. So I need to find a way to make them smaller without cutting down on quality. And that's something for some reason I couldn't figure out how to do at the time. So that's also something to look into. So I think what I'll do is I'll go ahead and try to get that stuff done this weekend. And I might go ahead and stream that because that might be interesting enough. But it will be on Saturday if I do that, Saturday my time. And then we'll go from there. By the way, after we finish Huffman Encoding, the next algorithm I'm going to go into will be kind of your choice between the fractal flame algorithm, a nodding algorithm, which will be kind of difficult for me to go through, and let's see, what's the other one? The other one would be the random number generator Mercine Twister. So I'm kind of keen to do Mercine Twister, just because as far as all three of these are collaborations with people, and that person specifically said to get this out in April. Meanwhile, the other two were kind of iffy on what time they want to do the collaboration. So I think probably doing the Mercine Twister one makes most sense. Okay, so let's go ahead and go through the depth first search, and then we go from there. So let's go in here, and let's do it. So depth first search isn't too incredibly complicated. We just read in the node that we want to work with, and then we just kind of go through the node recursively, right? There's a way to do this with a stack, which is more efficient than doing it the recursive way. So I guess let's go ahead and do it that way. Yeah, let's go ahead and do it that way. So let me think. Luckily, we have a chapter in the algorithm archive about this with Julia code already available. So let's go to the algorithm archive and let's go to tree traversal. Flip this guy up over to Julia, and let's see, depth first search. Easy enough, but I want to see the stack. Recursive post order, recursive in order, depth first search stack. That's what I wanted. I know this is very simple. I apologize for that. Sometimes I have trouble remembering exact implementation details when I start things. So here's what we're going to do. We're going to say that we have some sort of S, which is going to be equal to a stack of, yeah, I guess it's capital there, of node. And I think Julia has changed its syntax, so it's going to be node here, probably. So let's pop over here, and then what we want to do is push the initial node onto the stack. So we're going to do push, and what we want is ns. Yes. SN, dang it. Good. Next thing, what we want to do is... Oh, well, that's weird. Anyway, it doesn't really matter. The heck? Oh, I have caps lock on. That totally explains it. Okay, so now we're going to say while length in S is greater than 0. End it there. Okay, so basically all we do is we pop out the node, we take a look at the node, and then we push it back in. So let's go ahead and do it. So temp equals pop S for child in temp children push SN. So let's do it. So we're going to say temp is going to equal to pop exclamation mark of S, and then we say we go ahead and push S dot, oh, I'm sorry, temp dot left onto S, and then we push temp dot right onto S. And then all I need to do is add an exclamation mark here. And there. Good. Okay, so now we have that all pushed together. We have the depth first search working. So this should be relatively straightforward now to go ahead and create the bit strings. Now, one thing I need to put out here is this happens if there is a left and a right to begin with. So what I need to do is go ahead and put an if statement in here, signifying if we're on a child node or not. If we're on a child node, this becomes a little bit more complicated. So we have to kind of think about that real quick. So how do we figure out if we're on a child node? Basically, we'll say if temp.left equals, does not equal empty. Wait, I guess it's of type. Let's see, how do we find the type of an object in Julia? Isn't it just type of or something like that? Let's go ahead and run Julia over here. Let's just run type of 1.0. That didn't seem to work. Type of 1.0. There we go, great. So what we want to do is type of temp.left not equal to empty, which should be the correct type. Then we go ahead and push here. And that. And we basically do the same thing. So let's just go ahead and do yank, paste, change this to temp right, and go down here and end it down there. Okay, so now we have those pushed. Let's see, what's the last thing I need to do here? Well, I guess another thing I need to do is really quickly make sure that I didn't syntactically get anything wrong. So we're going to Huffman.jl. Okay, so syntactically this is okay. Now this is a depth first search, but the thing is, the depth first search should return kind of some sort of binary bit string value of some sort, right? So we should be able to have, like, every time we go left, we add a 0. Every time we go right, we add a 1. So that's important to note. So what I want to do, I think, though I'm not quite convinced this is the best way to do it, but what I want to do here is I want to add in another string, which will be the bit string. And then basically all we want to do is for the initial node here, and all the initial nodes that we have, we just go ahead and put in a 0 for basically all of these nodes that we work with. So let's go ahead and go down there and do that. So every time we initialize a node, not there, we just add in a 0 real quick. And then the next one, again, adding in a 0. Next. Okay, this should work. Okay, so now that we have the bit string in there, and we have the node initialized with a 0, in fact, it probably shouldn't be initialized with a 0 now that I think about it. It should just be initialized as an empty string. My bad. Let's go ahead and initialize it as an empty string. Okay, so what I'm going to do is I'm going to basically, every time we go right, we're going to increase the bit string with a 0, and every time we go left, we're going to increase the bit string with a 1. So basically we're going to say, push here, and what I want to say is temp.left dot bit string is going to equal to temp dot bit string, and I'm just going to say plus, we're going left, so I'm going to add in a 0, and now I'm going to do the same for right, except adding in a 1. Temp.bitstring plus 1. Let's go over here, run Julia real quick. Good, that syntactically works out. So now in this way we go left and right, and every time we go left and right, we increase the bit string by a 0 or 1, and so this way we can tell which way we're going. This is probably not the most efficient way to do it. There's probably another way to do it. So that's something I need to look into too. Bit string creation for Huffman trees. So chat's kind of quiet today, so I guess there aren't too many people watching. If you're interested in talking about literally anything, just feel free to talk about it in the chat. I'm of course up for talking about just about anything. You've seen these streams before, you know how they go. Thanks guys so much for coming in. If you're here, really appreciate it. So just feel free to say whatever you guys want, and we can kind of go from there. Okay, so we have the depth first search here. So now we're going to create tree. We have that. So now we have to go ahead and create the dictionary that we're going to work with here. And this, in the end, will return the dictionary that we're working with, which will be a dictionary between strings and strings, where one string is the character string, the other string will be the dictionary itself. Now let me think, what's the best way to do this? That's cool, not a problem. I'm just checking it out, making sure that everyone's still okay and that there's no questions, comments, concerns, anything like that. Also, I'm going to get some water before continuing here. So now we have the depth first search that goes through and creates the appropriate bit strings as we need it. Now the question is, how do we turn that into a dictionary? Well, I actually think, since we have this stack and everything generated up here, I think what I need to do is say if type of left and type of right are both empties, which means that we are on a leaf node, we go ahead and append to the dictionary there. So maybe what I need to do is, instead of calling this function depth first search, we say we call this function create dictionary, and say that within the dictionary we have a depth first search. I try to use a dictionary, and if the children name is a 1 character long string, I would add the bit string to the dictionary. All this is doing recursively is passing new bit strings. Some problems though, should in theory work. So you said you tried to use a dictionary, and if the children name is a 1 character long string, I would add the bit string to the dictionary. All this is doing recursively, and passing new bit strings had some problems though. Should work in theory. Okay, we'll go ahead and implement it this way. Again, this is another thing that we can probably optimize a bit later. So what I want to say is the following. If type of temp.write is going to be equal to empty, and type of, I'll put it on the next line, temp.left is going to be equal to empty, then we go ahead and append to the dictionary, and at the end we'll return the dictionary. So I guess, what should I call the dictionary? Hey, CSK, how are you? Thanks for coming in, really appreciate it. Mine's probably not better, just overly complicated. I think everyone's first attempt is going to be overly complicated, so that's fair enough. Mine's also probably overly complicated. There's definitely ways to make it less complicated. Hey, Buff Siegel, thanks for coming in, really appreciate it. Okay, so next what we're going to do here is we're going to go ahead and append to the dictionary that we're working with. So since we know we're on a leaf node, we know the character that we're working with here, we can just go ahead and call the dictionary something up here and kind of append to it down there. So what do we want to call this dictionary? It's going to be, in the end, the character map that we're working with here. Hey, and Perry, thanks for coming in. So what is the character map going to be called? I think, actually, they called this something really cool in the, what is it called? What do they call it? They called it the canonical Huffman Encoding. And I think they called it like a word bank or something like that. No syntax highlighting? Nah, dog, I kind of work just with VI. It's pretty easy. He's streaming in black and white to save energy. That's exactly what I'm doing. The code book, that's what they called it. The code book's probably a good name for this. Let's see, El Refriado de la Grieta. Julia. Yeah, Julia's pretty cool. What's going on here? Well, we are currently working on a project known as the Algorithm Archive. The Algorithm Archive is basically a bunch of algorithms put together into a single place. And right now we're working on Huffman Encoding. So that's pretty cool. If you're interested in more information here, feel free to go ahead and look at any of the stuff that we have. So we have like YouTube, let's see, I think there's like a YouTube channel here, that kind of stuff. Obviously we have Twitch and a bunch of different things. So feel free to also follow us on Discord if you're interested there. The whole point in the project is just to kind of get a whole bunch of algorithms into one place. And that's the idea here. So if you're interested in this kind of stuff, just kind of going through algorithm by algorithm, learning things together as a community, that's what we do. So right now we're doing Huffman Encoding. If you have questions on exactly what Huffman Encoding is, feel free to let me know, and I will totally go through that again in just a second. Let me go ahead and implement this function here, and then we can come back and talk about Huffman Encoding directly after that. Okay, so we have the function depth first search. Let's go ahead and create the dictionary, which we're going to say is the code book. And this is going to be equal to a dictionary. Let's see, dict. Let's see if I can get the syntax right here. So it's going to be a dictionary, and in the dictionary, we are going to have two different guys here. I think we're going to want a character, which I think in Julia is just char. And then after that, we have the string that we want to read into. Now, I think Julia is going to want something like this, so I'm going to try char here. And let's think. Over here, oh, you know what I can do? Get diff Huffman.jl. So key char, yep, that's correct. Good, clear over there. Okay, so now we have the codebook over here. Basically, at the end of this, we're going to return back the codebook. Great. Why don't you use a proper text editor? I'm using VI, it's pretty proper. Actually, I think I even have a command for VI. I'm not really sure. But basically, I've been using VI for years. It's what I used when I started. It's what I'm most familiar with. I could use Vim. Vim is basically VI, but improved. It's still just as good. VI works for me. I understand that if you don't like it, you don't like it. That's perfectly fine too. Okay, so let's go ahead and append to the codebook here. So down here, we're going to say codebook of the particular character value that we're working with here, which is going to be, let's see, temp.key. And this is going to be equal to temp.bitstring. Okay, so now we're basically going in from there. Vim, VI is what's good for dinosaurs. Vim is the other story. That's true. Or people that really know what they're doing. To be fair, again, text editing is one of those things I think a lot of people get really, like, for example, this whole war between Vim and Emacs, or VI and Emacs or whatever, like, people get really up in arms about text editors. I don't think your text editor really matters. I don't think your operating system really matters. What matters is that you're efficient with what you have. And if you know how to use what you're using, that's fine. Oh, yeah, I can use a simply configured Vim too. There's just a few things about VI that I kind of like, you know, that I kind of get just fed up with Vim. But again, I agree with you, Vim is better than VI. And if I'm telling people to learn a text editor, I always teach them Vim if they're asking between the two, not VI. But, you know, it is what it is. Hey, EchoDev, thanks for coming in. Yeah, I agree, people should use what they want. If people are familiar with one thing, they use that one thing. Now let me think, how do I convert a string to a character in Julia? I think if I do temp key of 0, that should work. Of 1, rather. So let's go over here and let's run Julia Huffman.jl, and let's see what we got. Okay, so this should, in principle, create the codebook. So let me go up here, and let's, I like the word codebook. I like that a lot. I like that name, codebook. Okay, so this will create the codebook that we're working with from there. So let's go down here, and instead of this create dictionary function, I think I'm just going to go ahead and D3D here, and then I'm going to DD there, and put this comment up on top of the depth first search. Where are we? Ah, here it is. There. Good, so now we can go from there. I would have to look at properties and methods all the time without auto-completion. Yeah, that's the thing too. Like, when I started the stream a while ago, I had the choice to, choose between text editor that everyone knew and loved or VI. And I was like, you know what? Screw it. I'm doing this in my own time. I'm doing this for fun. Let's do what I want to do. And I wanted to do VI at the time. Above Siegel, technically this just-in-time compilation, Julia does it slightly differently. So Julia is actually very fast and efficient because it compiles function by function instead of line by line. So it actually, now granted, I'm running from some old Julia here, like Julia 0.5, I want to say, but it actually works very well. And one thing that I like about Julia is that it can actually get speeds that are very similar to C in speed. So it can get speeds that are roughly 2 times that of C, which is really good when you compare it to like Python or other languages like that. So it actually works relatively straightforwardly and pretty well. I'm a big fan of it. Promo Hunt, too long, didn't read, FAQ, what is this OS? The OS is Arch Linux. I've been using Arch Linux since I basically started using computers, so it's what I'm most familiar with. Okay, so this map in here, I'm going to change this to be a codebook between a character and a string. And same thing down here. Again, I just like the word codebook for some reason. Codebook. And we're going to say character here. And we're going to have string down here, or character down here. Okay, so why use some exotic language? So the truth is, Julia is an up-and-coming language. It's not really exotic. It's one of those languages that people have been getting more and more accustomed to over the past year or so. The reason I really wanted to use Julia for this particular project is that syntactically it's easier to read than some other languages. Now, I'll argue that it's still difficult to read for some things. Like, for example, the typing of this, like phrase, you know, colon, colon, string, that's really weird. But to be fair, there are some things about Julia that are quite nice. Like, for example, calling function instead of, like, for example, Python's def. That's kind of nice. It has a whole bunch of things underneath that make it very quick and efficient. And it's just a clean language to write with, I think. It's not as complicated as C++ or something like that. So as you're reading Julia, you can get the gist of what we're trying to do without necessarily understanding Julia's syntax, unlike a lot of times with C++ or other languages. So that was kind of the thing. Echo Dev, I missed a question. What question did I miss? I see hello. So post a question in Adam's stream. Can you explain entropy real quick? Oh, entropy. What do you want? Do you want thermodynamic entropy? Oh, really important in the compression field. That type of entropy. Yes, it is kind of important. However, I kind of want to refrain from talking about it at this point in time. And the reason I want to refrain from talking about it is because I don't have a formal, good definition outside of the information theory one. But let me go ahead and show you that one. So entropy. I was going to put this into the algorithm archive, actually what we had before. But, let's see, how do I do this? So entropy is, in a thermodynamic sense, a measure of disorder in a system, right? It's kind of the opposite of information in a way. I don't really have a good way to describe it though, right now, is a problem, not for information theory. So if you don't mind, let me come back to this question as a discussion question in a bit. I'd like to talk about it in more detail, but I need to kind of compose my thoughts there and come back to that. So I have another few minutes here where I want to finish up the Huffman Encoding section that we have right now, and I'll come back to that in a little bit. I used to have a good way to describe this, and in fact I have a book around. One second. So I actually have my information and data compression book right here, because, I don't know, it's pretty useful, especially when you're going through Huffman Encoding. So I'll see if I can get you a better definition. And if I can't figure it out on stream, I'll send you a message afterwards with a better definition. Because I need to kind of think about it. I usually think about it in terms of information theory and stuff from there. I will say, though, a lot of new languages that are popping up are really nice and showing the flaws in some of the more established languages. Yeah, to be fair, I mean, people know the flaws in some of the more established languages. For example, Fortran. I mean, like, no one likes Fortran, right? For obvious reasons. Like, there's a lot of things wrong with it. It's got really legacy syntax in a lot of ways. It's hard to use in a familiar way for new coders. However, that said, it's still one of the most used languages in high-performance computing because it's still as fast as you can get for CPU-based number crunching. And that's really, really cool. So nowadays, they're trying to take Fortran and move it on to the next level. So, for example, everything past Fortran 95 has actually been really, really, really good. It's just different. Somewhere in the world done. This kind of display division is built into Arch. Fortran, my dad used it. No, this is not naturally built into Arch. What I have is I'm using OpenBox, and I have some commands to just naturally tile certain things. So if I press L, it just kind of moves it over here to the left, and if I press H, it moves it to the right. But also changes the size of it and does some other things. So I kind of have some inbuilt keybinds here. Fortran, my dad used it in university when he studied math. Yeah. Is that epic? I'm not sure. I don't know what you mean by is that epic. Okay, so let's go ahead and do the encoding here. So we have some sort of phrase. We have a dictionary between the characters and the bit string. So basically all we have to do for the encoding function here is go through all of the characters in the phrase and encode them into an overall bit string. So what I'm going to have here is, I guess I'm going to call it final bit string. And we're just going to set it equal to an empty string for now. And we're going to say for, let's say I in phrase. And here. And basically we're just going to say final bit string plus equals. And we should just be able to use codebook of I, and that should be correct. And then we should be able to return the final bit string at the end. Okay. So now we have the create tree here. We should be able to also, after creating the tree, create the codebook. And then after creating the codebook, we should be able to encode a phrase. So let's go ahead and try this out and see what happens. I have no idea what my view count is. I don't tend to look at that while I'm streaming, but I hope that's okay. Yes, I'm using OpenBox. OpenBox is one of my favorite Windows managers. Yeah, I really like OpenBox. It's super easy and it's good to use. That chat app, is it IRSSI? No, it is IRSSI, actually. Don Jurok, I have been up since 5 in the morning. I stream from 5 to 7 o'clock a.m. Japanese Standard Time every single day, or every single day I can. So I've been up for an hour and 11 minutes. Let's see. Hey friends, thanks for coming in. Void Dreamer, it's IRSSI. Yep, it is IRSSI. Thanks, N Perry. I thought so. Epic is a fork, but recalled Epic before I recalled. Oh, okay, I see what you mean. Yeah, then it is Epic. It's just IRSSI too. 70 people watching. Oh, that's quite good. Oh, cool. Adam, I didn't realize you hosted, but thanks a lot, man. Really appreciate it. Do not be aggressive towards other people. No name calling. Yeah, so basically what ended up happening was we had a troll a few years ago who just, for some reason, hated our one moderator we had. And just every time he came in, he just called this guy like a loser, and it wasn't nice. Like, this guy was mean. So I created these Twitch rules for that. Twitch chat is regular IRC. Yeah, I'm sorry. I should have put like Twitch alerts or something up. I just don't, I don't have that because a while back when I had the Twitch alerts up, a lot of people got mad that, you know, you kept hearing these like random things that kept appearing. So sorry about that. It's just plain old IRC. It's actually not plain old IRC. There's actually a few differences between IRC and the Twitch chat, but they're very small. Have you tried i3WM? No, I have not. I should probably try that in a bit. It's IRC with some extras, exactly. Okay, so let's go ahead and try this. So now we have to go ahead and create the codebook. And what we want to do is create the codebook with the tree that we created from the create tree. So in here we're going to say, oh, do I actually return the Huffman tree? No, I do not. Huffman tree. There we go. And so down here, we're going to create the codebook with the tree that we returned from here. Oh, so we're just going to say tree. It's going to be equal here, and I'm just going to call it Huffman tree like we did before. Down here, we're going to say Huffman tree. And here we're going to say codebook equals create codebook. So now we have the codebook, we have the tree. In principle, we can encode any phrase. So now what I want to say is the bit string is going to be equal to, what are we going to call it? We're going to call it encode. So guys, give me some phrase to encode here, and we're going to test this stuff out, see how it works. Might not work the first try, we might have some issues, but that's okay. So we want to do the codebook first, and then some sort of phrase. So you guys go ahead and tell me what phrase you want to encode. You can turn off sound on alerts. Yeah, I know I can. Truth be told, there's some issues with Linux and the, what do they call it now? It's not Twitch alerts, it's Streamlabs or something like that. But there's some problems here. I couldn't quite get it to overlay properly. There's some issues that I needed to fix that I haven't yet done. Let's see, Twitch chat is just regular IRC. What do we have here? No IRC network is plain old IRC, since the protocol has been evolving. Yeah, that's true. Thanks, Adam. Yeah, sure, I'll do that. Thanks. This also is not going to work. Oh, it's going to be sad. Adam, let's go. Chicken nuggets. Let's go ahead and right here, go over here, run juliahuffman.jl. Load error, fantastic. No matching data structure stack, node. Okay, good. So this is because I hadn't yet tested that one. So for create codebook at node, it's going to be 19. This is simply because I have the syntax wrong for the stack. So I think syntactically it looks something like this. 1 second, let's try that. And that. Write this, go over here, juliahuffman.jl. Dagnabbit. For plus string string. This is going to be in create codebook 27. Okay, so it doesn't look like I can add strings together in Julia. I thought I could. So that's something I need to look into, but we'll see that in just a second. Awesome, pretty nice Windows Manager. Today, I don't know what the today command is supposed to do, but if you tell me what it is, I can tell you what I need to do from there. The language is Julia. I think that Lemel-Ziv algorithm is easier to understand. Huffman is much more complicated. Could be. It's just I chose Huffman because Huffman is one of my favorite algorithms. So it's super, super cool. TS Joss, thanks. Oh, yeah, sorry about that. Why is it? Afternoon, morning. Hey, Ethan, thanks for coming in. Bosa Puetsu, sorry about that. We'll try Sway. I don't know what Sway is, actually. What are you doing today? We are currently going through Huffman Encoding, just trying to get a basic Huffman encoder out, written, and then we can kind of work on stuff from there. Again, the idea is that we're going to put this in the algorithm archive, so we want it to kind of be clean enough and followable that people can figure out what's going on. Maybe you meant to tag Simuleos? Well, let's see, what did... Oh, wait, yeah, maybe I missed something real quick. I apologize for that. I'll take a look at that in just a second. Okay. Sway is i3 clone for Wayland. Oh, cool. Okay, here's the thing, guys. Before continuing, I have to take a brief side note with Wayland. Do you guys know, is Wayland actually used frequently? I know it's used for the GNOME desktop now, and I think it's used for KDE. But isn't it still X-Wayland? Like, it's not Wayland proper, right? Like, it's X-Wayland. If you guys know, feel free to let me know, because I've been trying to figure this one out. Because I've been wanting to switch to Wayland. Actually, I wanted to create an open box, like, kind of for Wayland. But I feel like it's already been done now. And this was like a few years ago. And Wayland's one of those things that has been slowly growing over time. But it hasn't yet gotten to the point where it's, like, used officially. And it's been, like, 5 years. You know what I mean? Like... if anyone has updates on Wayland, let me know, because I'm super interested in that. Okay, so the issue is, for some reason, I can't add strings in Julia like that. I thought I could. So let me go ahead and go here, and let's run Julia. And let me try something real quick. So I'm going to say x is going to be equal to the following. And now I just want to do x plus, let's do another string. That doesn't work. So maybe there's like an append function. So let's do x, 0. Nope. Let's Google it. I know this is really dumb. I'm sorry. My Julia syntax is very poor. Or rather, my understanding of Julia is very poor. I'm trying to learn the new language as we're going along. X type of answer. That's great. I just want to add the characters together. Concatenate. Maybe it's vcat? There's a way to do it. String. Oh, it's just string. Let's do x and 0. There we go. Of this. To be fair, that was not syntactically like standard, I don't think. So let's do string here and the following. Okay, in principle that should work. And let's go over here, Control D, and run juliahuffman.jl real quick. Now what's this load error? No method matching push for node data structure stack. Closest candidates are abstract array. Let's see what we have. Let's see, what did I miss over here? They always use X Wayland. Okay, cool, fair enough. Thanks guys for that. Let's see, temporary bit string equals string. So what I'm missing now is 28. Yeah, Julia it's good. It's fast, it's effective, but it also writes like Python. I'm a fan of Julia. However, there are some issues with Julia that I have to bring up. If you want to use it for a project, it's mainly used for number crunching and stuff like that. So it's kind of like a MATLAB replacement type of thing that's not proprietary and isn't frustrating to use. It's also kind of in development still. So as you kind of go through things, you might notice that some of the things you wrote like a month ago might be deprecated. Now there's some issues there. But ultimately, I say that it's a good language and it's worth learning. Hey, that's your fan. Thanks for coming in, man. So what I'm going to do now is pop back up over to the algorithm archive real quick, where we have the tree traversal stuff, and let's sing. I do have push here, but maybe the syntax has changed since the last time I did it. So no method matching push node data structure. I think though I just had it backwards. I'm pushing onto the stack the temp node here. Left. And same thing over here. And then I think that should work. Julia Huffman.jl. T is not defined. Cool. What is T? Encode on 81. Final bit string codebook I. What? Key T is not defined? Oh, I see the problem. Good. Okay. So that means that the encoding didn't quite work. That there is something that we're missing from that. So what I want to do is go ahead and output the codebook that we have here and see what we're missing there. So we're going to do print line of codebook. And I realize it's going to be on more than one line, but we'll just see what happens. We have HER, which isn't even... Oh, I know why. I did this incorrectly. I'm an idiot. I apologize for that. Let's pop down here. Let's change this. But HER is still wrong. But anyway, let's see what happens. So what I want to do is thanks Adam, and I think I know the problem. The problem is I need to do here. Julia Huffman. Looks like everything's in there. So now if we check out the bit string here, DDX, and let's do print line code word. Oh, bit string. Okay. With that, go over here and let's run Julia Huffman.jl. Load error, fantastic. No method matching string. Oh, I must have done that again. That's here. So final bit string is going to be equal to final bit string bit string and then codebook of I. So let's do Julia Huffman.jl. A is not defined. What? A. Let's see, 81. Did something stupid there. Let's see, what do we have here? Oh, I've been wanting to do something with Huffman for a while. Oh, cool, playing with scissors. Cool. We're doing Huffman right now. Right now, the algorithm archive just has a basic chapter on data compression. Not so much here. We did a discussion earlier today about Huffman encoding. Right now, we're getting the basic code written, and we'll put this into the algorithm archive in just a bit. So, do text compression algorithms use a table of common words like the, which they reference to save more space? I don't really know of all the other text compression algorithms. I just know of a few, and the one that I know of and that we're working with right now is Huffman encoding, and this works usually on a character by character basis. So it doesn't know the word the, but it knows that, for example, maybe T is used more frequently than any of the other characters, if that makes sense. So then T uses less bits. Actually, you know what I'm going to do after I get this encoding working? I'm going to go back through and explain Huffman encoding for all the new people that came in so that you guys can see what it is that we're doing exactly and go from there. So give me just a second to get this codebook working and then we can go from there. So in code, it says gen index dict key A not found. That is interesting because I thought I just checked. So let's go here, comment this out, and let's go ahead and do print line of codebook here, and let's see what we have. No semicolon necessary in Julia. Julia Huffman.jl. It is because the A is capital. Oh, that's not that one. N A T M D 00 K. You're right, A is not there. Why is A not there? Huh. What is algorithm for? Huffman encoding is like the standard data compression algorithm. It's the one that you hear of most frequently. It's the thing that basically takes all your text, puts it into bits, and then minimizes the number of bits that you're using for that text. So it's kind of like what you're used to hearing when you hear about data compression. But you are right, there is no A. So let's see why there isn't an A, but there are the other characters. So T, A, N. Why would the A just be missing? M, D, K. Oh, the A is the most frequently used letter, I bet. Yeah, A is the most frequently used. So maybe this guy. 0000. No, it should be the fewest characters here. I'm watching Adam while at work when I returned from a meeting and he was gone. Glad he hosted someone as interesting to watch. Yeah, I'm glad you enjoyed the stream. Case sensitive, A is there, capital A is there. But actually, I think I know the problem here. So A is the most frequent character here. So I guess now is a good time to talk about Huffman encoding since we're talking about it. So new page before. We've had this discussion before and we talked about it earlier today, but here's the idea. Let's say we're encoding the phrase HELLO. We take all these characters out and we put them in order based on what is the most frequent character used. So in this case, the most frequent character used is L, with a frequency of 0.4. It occurs twice out of 5. Then we have H, E, and O, all used equally frequently out there. So H is going to be 0.2, E is going to be 0.2, O is going to be 0.2. So now what we do, it should be in long text, you're right, playing with scissors, but for now we just kind of have something very basic to show. Already being a better artist than Adam13531. Yeah, to be fair, my art's really bad too, so don't judge me there. So then we have, let's see, we'll add these two guys together, which are the bottom two guys together, to be 0.4. We add these guys together here to be 0.6. And we could do it either way. We could add the 0.4 and 0.2 there to be 0.6 and 1.0 here. So we add them all together to get 1.0. Then we traverse back through the tree to figure out what the bit strings are. So every time we go up, we put a 1. Every time we go 0, we put every time we go down, we put a 0. So 1 0, 1 0, 1 0, 1 0. And so now we have a code book, L, H, E, O, which is going to be L is 1 1, H is 1 0, E is 0 1, and O is 0 0. And then we use this code book to in order to encode the string. Now, if you want to see an animation of this, we do have an animation up, which I think is quite clean and clear. So I'll go ahead and show you guys that animation. So let's go ahead and do a quick ls, and let's do, I think it's just Huffman.gif, garage, Huffman.gif. So this is it for a longer string, and this is basically the Huffman encoding of the string. Wait, what string is it? Oh, Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown, and Jill came tumbling after. So that's the animation of that one right there. So as you can see, depending on how far away the character is, so for example, the space is the most used character in that string, so it's way up here on the tree. The T, exclamation mark, dot, and G are the least used, so they're all the way down there. The more used characters generally have fewer characters or fewer bits in their bit string than the final one. So all the way down here, we have a very long bit string because these characters aren't used very frequently, but up here, because the space is used so frequently, it only has 2 characters in the end. And that's pretty cool. Actually, I used GIMP for this animation, or not GIMP, I used Cairo for this animation, which is kind of like the underlying guy behind like Inkscape and stuff like that. This was done in C++, this one. So, but the language that I'm using overall is Julia for today's stream. So yeah, 0204. Oh, so the numbers here, they come from how frequently the characters appear in the string. So for example, L appears twice out of 5. So because it appears 2 times out of 5, its frequency is 0.4. H is 0.2 because it occurs 1 time out of 5. E and O also occur 1 time out of 5, so it is 0.2. Julia is the best for algorithms. I would say that Julia is good because it's easy to read, but I think any language is really okay for algorithms. It just depends on what you want. Playing with scissors. What did I miss? I feel like I missed something. I'm a developer and I use GIMP. Seems like all the pros are using Paint though. I need to switch. No, I'm not using Paint. I'm using Zernal for this one. But yeah, you know, use whatever you want. It doesn't really matter too much. I've actually been using Krita recently. Have you guys used Krita? It's pretty dang good. I'm a big fan of it. Okay, so in this phrase that we're encoding, which is thanks Adam, new page before, the A, the lowercase a, is the most used character, which means it's the first character on the tree. So let's actually just take this. So thanks space Adam. Okay. Also, this music's a little bit weird. So of all these, I think A is the most used, A, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Am I doing that right? 4, 4, 8, yeah, 11 characters total. So A is the most frequent, and it will be 1 over 11, let's say. 2 over 11. Everything else will be 1 over 11, so it's not so important what everything else is. So then we have T, H, N, K, S, space A, D, and M. Cool, that's what we have. And as we add up the tree like we did before, it'll turn out that this A is going to probably have fewer bits than anything else, so it's going to be at the top of the tree. And so for some reason, we're missing it, and I'm not exactly sure why. So I'm going to go ahead and look at the depth first search and see what we have. Why doesn't it just order them by how many times they are used, and then assign a byte representation, zeros and ones, from the shortest to longest? Why is it a tree? So it's a tree for the following reason. Page, new page before. I know what you're saying. We can assume, like, we can just create some sort of byte order and things that works based on, like, what's the most frequently used. But let me go back over here. Page, new page before, or just previously. We have, here it is. Okay, so for this hello, we could have encoded it in 2 ways. We could have encoded it 0001 1011, like we did before, or we can encode it 010 110 111. These are 2 different encoding schemes, both of which are accurate with Huffman encoding, and both of which compress an equal amount of data. However, there's a trick to this later dictionary over here, or this later set of code words. This set of code words here, note that L is 0, and then H is 10, E is 110, and O is 111. In no case does H, E, or O ever use 0 as a prefix. It never uses 0 at the start. The reason we use a tree and an auxiliary data structure to do this is because if we have a tricky book of code words, then there is really no way to ensure that this book of code words is prefix free outside of kind of creating this auxiliary data structure to do so. Now, I will note that there's other ways in order to create a set of code words that does work and does compress data. There is Shannon encoding, and there's also Shannon-Fano encoding, which will both do the same thing, which is stuff that I'll cover in the future, but they're kind of historical algorithms that aren't really used in the present. So the kind of reason that we want a tree for this is so that we can ensure that the book of code words is, first of all, maximally compresses the data, and second of all, is an appropriate set of code words that we can use to greedily decode our bit string in the end. Yeah, so it ends up as a string. Just install Krita, it looks pretty nice. Yeah, I'm a big fan of it. When you encrypt and decrypt the tasks, you either take a left or right to find out which character it is. Yeah. Let's see, what do we have here? Why does it just order them? Oh, that was your question before. Cool. Okay, so here's again that animation. So what we need to do now is figure out... I feel like I missed something. Because you need to be able to individual... Yeah, actually, you're right, JSPP, that's not incorrect. Yep. Okay, so let's go ahead and figure out what's wrong with the encoding here. So I think there's a problem with our create codebook function, and that it's somehow missing the most frequent character, which is probably a big problem, I would say. I'm not exactly sure what the problem is, but again, this is pretty simple code, so we should be able to go through and figure it out. What I want to do is just, again, this is really stupid debugging, but I'm going to go down here, and I just want to output the key. So I'm just going to say print line, and I'm just going to print line of temp.key. And let's see what happens. So I'm going to run Julia Huffman.jl. Yeah, so it is missing the first A. But note that there is an empty here. Set as 0000, so I don't think that's quite right. Yeah, so that animation was done actually years ago. I have not put this in the algorithm archive because we didn't have the algorithm archive back then. But now we do, and now I'm going to put all this kind of stuff into the algorithm archive and go from there pretty soon. Okay, so why is A being missed? We're going through, and basically this is a standard stack-based depth-first search. We have the codebook, which is a dictionary between a character and a string. The string will be a bit string that we're working with in the end. We basically say while length of s is 0, so while we still have items in the stack, we pop s, we look left and right, and then we basically put left and right nodes back into the stack and go from there. All the while appending to the bit string. What we say is if the type of the left and right nodes are both empty, so that we don't have a left and a right node, then we say that we're going to put the key into the codebook. And it gets it most of the time, but we're missing the A. So the question is, why is it missing the A? And I'm not really sure about this one. So I'm going to have to kind of think about it and figure this one out. So how about we do the following? What I want to do is every time we go through, I also want to output, instead of just the temp key here, I want to output the bit string as we have. So let's output temp.bitstring. Bit string here. I don't know what I was trying to do there, but that was not correct. Go over here, juliahuffman.jl. 110. This seems correct. 10101. So let's see if we can figure out where A would be in this case. Temp.key1 is not 0. If both empty. Let me think. So the temp.key1, what I'm trying to do is just grab the character of the string here. But what I can try, the first character of the string, and the character should just be a single element. So temp.key1 is not 0. Oh yeah, sorry, Julia starts counting at 1 instead of 0. It's kind of weird, but it is what it is. So I think if I put temp 0 here, I think we'll actually have a problem. Yeah, so it says cannot attempt to access K at index 0. So it unfortunately starts counting at 1. That was one of the things that I don't actually like too much about Julia code, but it is what it is. So let's see, we have 1, 1, 1, 1, 1, 1. Then we have 1, 1, 0. I want to say that in the end, 1, 1, 1 should be lowercase a. But it seems to me that we don't have 1, 1, 1. Because that's definitely a leaf node. We know it's a leaf node. But for some reason, it's not appearing in the codebook. To be fair, Fortran also starts counting at 1. So as somebody who doesn't know anything about Julia, this seems like that would be it. Well, again, we're getting all the other characters here. For some reason, we're just missing A, which again, I think is on node 111. And in fact, when we just output the key, let's just do print line. Let's print line of some key here. So let's just do temp.key. And let's just do 1, just to make sure we are outputting what we want to output. Let's do juliahuffman.jl. 111 is actually K, 110 is S, 101 is N, 100 is D. Am I doing something stupid here? One second. Maybe I'm missing create tree. So we have the priority queue here. So let's see, how are we doing this? Maybe I'm just missing one of the strings here. So we say while length of weights is greater than 1. We say weights is a priority queue. How do we say greater than 0? This has an A in it. That's good. Bit string not defined. We're getting there. We're getting there bit by bit. Okay, so 1 second. I've got to go through here and remove these print lines because they're no longer necessary. So DD there. There's a DD there. Now let's see, what do we have here? 97. N, 2 pass Huffman. Oh, bit string's not defined. Julia. Good, okay, that seems to work just fine. Great. So now we have this version working. We don't have the decoding in yet, but there is some stuff we kind of need to talk about because I said I would talk about it. So let's take now, since we have the encoding working, to go from there. There was just, I was off by 1 in one of the counts. If anyone was watching, that was the issue there. Okay, good. So now in principle, this should work. And in fact, it does seem to work. I guess we can try this with hello one more time, just because that was a very simple phrase that we had encoded before. So now that we know what it's supposed to be, codebook not defined. Well, never mind. Now I'm running into errors again. 92. Bit string encode. Codebook, Huffman tree. Oh. I accidentally deleted the wrong one. Create. And we want to read in the Huffman tree. Now let's go ahead and delete this guy down there. juliahuffman.jl. And since we know what the tree is supposed to look like, let's go ahead and see if this works. So it should be H E-L-L-O. So what do we have here? It says 001. It's probably 0010. Let's output the code book again. I'm sorry about that. 0111 001000. Good. Okay, so now we have the H, which is 001, the E, which is 000, L, which is 1, L, which is 1, and then O, which is 01. Works just fine. I made a physics simulation for tossing a coin, and I tried to figure out the thickness needed so that a coin lands on its edge if a third of the time. What do you think the result is? You just created a triangle, I guess. I'm not sure. Off by 1. 2 most common errors. Yeah. Don't you love it when that happens? Yep, totally true. Okay, so this seems good enough for me. Let me think. There was someone who did something about this. Like, if you toss a coin up in the air, the thickness has to be... I don't remember what the thickness has to be. Huh. Well, that's something to consider. I don't actually know. But I assume you just did the simulation. Okay, so we had to talk about entropy. Now, entropy is one of the things that I used to have a good definition for, but I don't honestly anymore. There is this definition of entropy that's based off the microstates and macrostates of a simulation or a situation, but it has to do with the probability density. Basically, how do I put this? Let me see if I can get a good definition of S or of H. Let me think. H is P log P. I'm trying to remember why that's the case. Let me just look up thermodynamic entropy. Because I remember them being the same thing minus some constants. K log, yep, it is the same thing. It's just with a different constant out in front. So here we have P log P, and here we have that guy. Now, why is it that case? I'm trying to remember correctly. So I think, so it has to do with your microstates and macrostates. If I remember correctly, here's what I know, and then we can kind of work off of this. If you guys remember more, feel free to hop in and we can talk about it. I know I'm a bad physicist. I should know entropy pretty well, but it's been a while. I got that the diameter is 1.9 times the thickness, although the more torque and velocity, the higher the probability of landing on the edge of the coin. Wait, the higher the torque. Huh. That's super interesting. Didn't Matt Parker do a video on that? Oh yeah, it was Matt Parker. Yep, sounds good. I remember watching a video from him. Let's see. It's weird that the faster you spin, the more likely it is to land on its edge. Why would that be the case? Anyway, I'm not really sure. So here's what we have. Let's say we have so we have a bag of letters, right? So the phrase H-E-L-L-O, imagine that we create the frequency by basically taking all the characters, putting them in a bag, shaking up the bag, and then pulling out a character by character, right? You'll have a 40% chance of getting an L and a 20% chance of getting any other character. This is a probabilistic thing, right? So if we have instead like a coin toss or something like that, and we have like 6 coin tosses in the row, there's basically a potential for having all of these different states. So let's say we have a coin toss and there's 2 possibilities. There's heads and tails. If we just toss a coin once, we have heads and tails, right? Or tails and heads. So basically we will land either on heads or on tails. If we toss it twice, we have the following possibilities. We have heads, 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 tails, tails, heads, and heads, heads. If we toss it 6 times, we have heads. 3 times we have heads, 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 tails, heads, tails, tails, heads. Wait, tails, heads. Okay, 1 second. Now we have tails, heads, heads. I got this. Tails, heads, tails, tails. 1 second. Tails, 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 heads. How many is this? 1, 2, 3, 4, 5, 6, 7, 8. I'm missing one. Which one am I missing? There's 9 of them. Ah, crap. I did this wrong. I should have just counted up bitwise, but I didn't because I'm an idiot. Let's see. Let's try this again. Heads, heads, tails. Anyway, it's 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, oh, 0, 1, 1, 1, 0, 1, 1, 1. Wait, is that the correct number? 1, 2, 3, 4, 5, 6, 7, 8. Maybe there are 8. I'm sorry, I did that wrong. You guys are right, I'm sorry. So the probability of you getting any of these basically follows a Gaussian distribution, right? So the probability of you getting heads, heads, heads is much lower than the probability, oh, rather, I'm sorry, I did this wrong. So now we add this up. So the probability of getting, let's say, I'm gonna draw it up here in the corner here. The probability of getting 0 tails, 1 tails, 2 tails, and 3 tails are the following. So you have 0 tails, you have 1. Ooh, this graph is going to be really ugly. I'm sorry about that. Having 1 tails is going to be, let's see, you should have 2. Probability of having 2 tails should also be 2. No, it should be 3. 3, 3, 1. I think that's correct. Let's see, 1 tails is here. 1 tails is here. Yeah, so it should be 1. Yeah, that's correct. Okay, so then we have some sort of distribution. And the thing is, the more flips we have, the more likely this is to follow a Gaussian distribution, right? This is kind of not really Gaussian-like because we only have 6 tail flips, but imagine we have 100 coin flips, and this turns into a Gaussian distribution. This individual element here is how many tails you have. So if you have 1 tails, then this is, change your unit to millions of tosses. Yeah. So if you have 0 tails, this is a particular microstate, right? So you have a probability of achieving a of 1 microstate over the kind of like the macrostate, which is all of them added together. Entropy basically is this measure of Now here's where I get kind of iffy because I don't remember after this point. But this is your probability distribution, and you have some sort of logarithm here. I used a different physics engine, but the results are very similar to mine. Interesting. Which is the coin size edge? Oh yeah, this is exactly right. Ooh, look at that graphic. Ho-ho. That guy knows how to draw. What's his name? I'll send him a message asking if he can help with the algorithm archive. Oh, he actually did the experiment. No way. Oh, no, he didn't. That's with Blender. Oh, pretty cool. Anyway. Okay, so now let me think if I can figure this out right. Now, thermodynamic entropy basically says, let me think if I got this right. I'm probably going to get it wrong, so I need to kind of figure this out. Okay, this is where I get fuzzy. I know that it has to do with probability. I know that there's some issue here with kind of like time, you know, like as you move forward. It looks like 3D word art. It could be. Man, shoot, I have this. I even have a video on entropy up, but it's thermodynamic entropy and talking about Maxwell's demon. And the entropy there is slightly different. It basically says that things get less and less ordered as time goes along. So basically what we're saying with entropy is that as you increase the number of elements that you're flipping, you're more and more likely to create this Gaussian distribution. That's basically all it's saying. But I'm trying to remember how this relates to the exact definition. And I think it's that you have the probability of finding this state is always going to be lower than the probability of finding this state, if that makes sense. But I need to find the exact definition there. It has to do something with the logarithm of the probabilities of finding one state as opposed to all the other states. And basically all it says is that as you add more and more coin flips here, you become more and more likely to find a center solution than a fringe solution. So the reason entropy is interesting is because, page new, page before, a long time ago we did the simulation of something called Maxwell's demon. And I realize here I'm kind of conflating the two different types of entropy, like information theory entropy and thermodynamic entropy. But hear me out, this is kind of a good physical, intuitive thing. So if we have a bunch of particles over here on the left, and a bunch of particles here on the right, based off of diffusion, these particles will come together and they'll basically form what you would expect. Some sort of, I guess you could say some sort of gas that is thermalized, and we have basically all the particles moving at some average speed. Okay? So now we have some sort of thermal distribution. If we change this up a little bit, so we have some sort of thermal distribution, but we put a barrier in the middle, a barrier that's called Maxwell's demon. And this barrier only allows very fast particles to move one way and very slow particles to move another way. Then we'll get all of the very fast moving particles on one side and all the slow moving particles on the other side. Now, this is a very, very unlikely result. It's not very likely that without some sort of external force that we could take a box, shake it all up, and then all of a sudden have the box be perfectly ordered after shaking it up. But that's basically what we're saying here. We take a box, we let it sit for a while, then all of a sudden all the cold particles go one way and all the hot particles move the other way. That's not very likely. What we're saying with entropy is we're basically saying that the probability of finding our system in this state is very, very small without some sort of external force, in this case Maxwell's demon, that reverses entropy. And there is no such physical force that can reverse entropy in a physical sense. Now, with information theory, if you do the smallest number of flips possible, it's possible for you to get kind of a weird state. But ultimately, as you add more and more time, or more and more flips here, you'll get to a kind of average state. And that's kind of what we're saying with the information theory entropy there. Okay, so I think what we're going to do is we're probably going to close stream with this discussion here. However, since I do have a few more people watching than normal, I'm going to ask you guys if you want me to host someone at the end of the stream. So if you do, feel free to let me know who it is you want me to host. So let me go here, and let me just go to, I'm pretty sure I got a message from someone, but I have not yet checked the message. So I'm going to go over here, and let's just go to, I guess, the programming category. So let's see, browse, creative communities, cosplay, programming. If you guys have anyone you want me to follow or you want to watch, feel free to let me know, and I will host that person at the end of stream, which will be closing in about 10 minutes. So that is about that. Good. And now let me think. What else do we have to do? I think we'll implement the decode function tomorrow. It's not actually going to be too complicated. I just have to flip the dictionary around. And also tomorrow we're going to look into something else, which is canonical Huffman encoding. So I've got a list of a couple things that we're going to go through tomorrow. Again, it will be same time, same place. We have to, 1, find a cleaner implementation of the binary tree. That's something I've written down. And maybe look into using the nullable node that we can use there. We have to look into a better way to create the bit string creation for Huffman trees. And this is just because as I have this node set, I'm basically having an additional like bit string data structure, a bit string data that's going to be moving along all the nodes. Like as we're doing a depth first search, we're holding the string as we're moving along. So that seems kind of inefficient. We have to implement the decoding structure, the decoding function. And then finally, we have one last thing we need to do, which is, let's see. Playing with scissors, thanks. I really appreciate that. So then the last thing we need to do is, look up canonical Huffman encoding. Now this thing's really cool, but I don't really know much about it. Canonical Huffman. So this is something I'm looking up, and I'm hoping to send most of the time going through this tomorrow. If you guys come tomorrow, so tomorrow at 5 o'clock in the morning my time, which will be basically 2 hours before whatever time it is your time, I'll go through a description of Huffman encoding and all this kind of stuff and explain what we've done so far, why we're doing it, all of that kind of stuff from the beginning. So if you come at that time, I will show it to you there. Also, if you take a look at either some of my previous streams, one of the past 2 streams, and just look at the very start of the stream, you'll see basically me going through Huffman encoding there. And if you go to, let's see, what else is there? Or the YouTube channel that I have with stuff in there, you can also go through there. I'm going to have to go through everything from the start anyway tomorrow because we're going to have to describe what canonical Huffman encoding is, why it's different, this kind of stuff, which I only vaguely know. So let me also write this down. Okay, so I'm not seeing anyone you guys want me to host, but I'll wait for a little bit longer to see if there's anyone there. So canonical encoding. Okay. AM and PM inverted. Wait, where do you live that AM and PM is directly inverted? You must live somewhere in Canada then, I would think. No, that doesn't make any sense. No. I know that it's 5 o'clock PM in the Eastern time zone of the US. almost 6 o'clock p.m. I don't know anyone you should host. Okay, that's okay. Added would host Bouncy Boy. Who do we have here? I'll host him if you're interested. Programming, quick guy here. Argentina. Okay, yeah, that sounds good. Bouncy Boy. Where's Bouncy Boy? Doublrog, play. Let's see. What'd you say the guy's name was? Bouncy. Boy. Oh, is this guy live? Oh, he is live. Okay. Oh, but this is a gaming streamer. It's probably okay. I don't mind. Yeah, I don't mind. We can host a gaming streamer if that's what you want. Not a big deal. Good. So I think that's probably good to go for now. I'm gonna go ahead and commit this to GitHub. Again, it's on the Simuleos directory. Git commit Huffman.jl. It's really nasty. I'm sorry. Adding test for Julia Huffman. I guess version, something like this. Git push. Origin master. Now it should be available on GitHub. Okay, again, guys, if you are not familiar or you're new to the stream, feel free to go to the Discord that was just linked in chat, and feel free to check out, YouTube, or the algorithm archive, all that kind of stuff. Should be linked under the stream, and that should be good to go. If you don't have anyone else to host, I'll take user specific. Like, if you guys want me to host Bouncy Boy, I'll host Bouncy Boy. Sounds good. And that is good to go. Okay, guys, thank you so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, when we go back through Huffman Encoding, start working on canonical Huffman Encoding, and do a whole bunch of stuff there. Thanks again, guys, for coming in. Thanks, Adam, for the host. I really appreciate it. And I will see you guys next time. And I will host Bouncy Boy at the end of the stream. Thanks again, guys, and see you next time. Bye, guys.